So today, we're going over lesson four. Lesson four is going over the structure of the Earth. Structure of the Earth. Alrighty. To understand the structure of the Earth, we're kind of zeroing in here. So we're going to look at the crust of the Earth. So when looking at the crust of the Earth, we're looking at that solid piece of mass that we are sitting on right now. Now, there are multiple different layers when it comes to the Earth. There's that top layer, the crust. Now, there's two types of crust. There's that oceanic crust, and then there is that solid continental crust. Continental crust is what we sit on now. That oceanic crust is that crust that you see at the bottom of the ocean when you're watching, Finding Nemo, things like that. Then we get into a lower level. We get into a lower level called the mantle. The mantle. Now the mantle is that magma under the earth. That magma under the earth. If you've ever seen a volcano has that top layer of crust there. That is our crust. And then the lava spewing out of it is part of that mantle, that molten lava. That is usually made of iron and nickel. It's melted down. It is hundreds of thousands of degrees hotter than the Earth's crust. Is very hot. So it's pretty much melted down series of metals. So that is the mantle. Then we're getting on to the outer core. The outer core is getting closer to the deeper part of the earth where it's molten, but it's almost solid, but it is so incredibly hot. It pretty much causes the shifting and movement of the rest of the stuff inside the earth. Now, this amount of metal creates what is called a sort of force field or a magnetic field. This magnetic field is kind of in relation to the metals kind of creating an electronic force. Now, this magnetic field kind of surrounds all the earth. That magnetic field affects the animals and human beings. So, for example, this magnetic field works as kind of like a GPS thing. Our world is very interesting. Birds, whenever they're traveling, they use that magnetic field that is naturally created in the earth, and they know what direction they're going because the field has a certain consistent construction. That magnetic field is always also, why compasses work. If you have a compass, it's always directed due north because of that invisible magnetic field. That invisible magnetic field aligns the earth and gives us direction. So that's very important. Then at the center of the earth, you have the iron core. Now, the iron core is solid iron. It is solid iron. And again, it's responsible and important for that magnetic field to have a consistent spread of magnetic energy. If you want greater clarification, ask your science teacher about that magnetic field. So that part of the earth is essential to us. So next, we're going to continue to a next very important topic, is the concept of the theory of tectonic plates. So the theory of tectonic plates pretty much is trying to explain rudely, as humans, why earthquakes happen. And we're trying to figure out what is the reason why these things happen. So this is a scientific theory. Remember, there's a difference between theory and law. Theory is a wide range of ideas that have been tested, and proven to be factual, while law is something that is essentially a part of the universe. Now, we're not going to get into other theories, but this is a scientific theory that explains how earthquakes happen and how the crust of the earth moves around. We'll get into more detail right now. Next, we have to understand the lithosphere. Now, the lithosphere is pretty much that top layer of crust. That top layer of crust and going all the way down to that top layer of the mantle. Those two sections are essential for us to understand what exactly is going on in regards to tectonic plates and how they play a role in our world. So if you understand what the lithosphere is, that solid, hard stuff going all the way down, this is including the ocean's crust, all the way down to that top part of that mantle, then we can understand what is going on in relation to the plates, tectonic plates. So pretty much understanding tectonic plates, there's the concept of tectonic plate boundaries. So when understanding tectonic plate boundaries, wait, did I skip here? Oh, no, it's right. So when understanding tectonic plate boundaries, these boundaries are very important for us to kind of understand what's going on in relation to the world and what these plates are doing. So these tectonic plates are large, giant plates which are all over the world. These tectonic plates shift and move, and that is why we're able to be on our continent. Now, each continent is pretty much a giant tectonic plate. So you got the North American tectonic plate. You got the South American tectonic plate. You got the African tectonic plate. You got the European, the Eurasian tectonic plate. Got the Australian tectonic plate. And these things are moving around all over the place. If you probably learned this in the class, but our Earth used to be connected together. All the continents used to be one solid mass there called Pangea. And because of tectonic plates moving around on that magma, then you get that shift and that separation and movement. And that happens over hundreds of thousands of years. So to understand tectonic plates, you have to understand a different type of tectonic plate boundaries. Now, naturally, as we have in society, we humans have boundaries, we have borders. So you got a border line. Tectonic plates have boundaries and borders too, that kind of line up and kind of go into different sections. So you have three different boundaries. You have divergent boundaries, you have convergent boundaries, and you have transform boundaries. These three boundaries are the main boundary types that we have in plate tectonics, and those play a role in how the Earth looks like and also play a role in earthquakes. So one of our first set of tectonic plate boundaries is divergent. Now you can imagine two giant plates sitting on top of each other. Divergence, you think of divide. Divide means to separate. So they separate and they move away from each other. Usually what this does is that it allows a giant gap. This would cause earthquakes because it's a shift in the land, and it would also create new bodies of water because that space on the upper lithosphere would allow for the oceanic plates to kind of shift also. So you would create like a shift in the water areas. A great example is the Mediterranean Ocean. The Eurasian and the African plate used to be closer, but once they've separated and diverted, they create that Mediterranean Sea. Another one is convergence. Convergence, you can think of the first two letters converge or CO, come together, they collide. So you get a collision going on. You get a collision going on. And there's different types of colliding. Sometimes the plates collide, and then one slides up on top of another. And then one continent kind of dips down below into the magma, and then one continent kind of rises up. This is why we get mountains. If you look at the Indian continent, the Indian subcontinent, you get those huge mountains like the Himalayas. Those mountains are created because of converging boundaries. One continent goes up, they both might go up and go like that, and then create a mountain. There you go. So convergent boundaries also are influential in creating earthquakes. It's a massive shift in the land. It's a lot of pressure. It's a lot of movement. Lastly, we have transform boundaries. Now, transform boundaries are plates that slide and grind one against each other. So they come together and slide, creating a rough shifting against each other. This creates a nice grind of the different plates. That grinding of the different plates creates massive earthquakes, which again causes a shift in the land. So main things to get out of this is that plate tectonics is that theory on how the different tectonic plates move around together and how we get earthquakes and how the earth crust is constantly shifting. You can know that the earth and its continents are constantly moving. Millions and millions of years from now, if we are still here as human beings, the earth won't look the same as it is because the plates are constantly moving. Alrighty, guys, that is it for lesson 4.